So we're on page 121, and we're going to do problem 1F, 1S, and 1U, F, S, and U. And we're also going to look at and go through problem number 2. So page 121, topic 21, let's start off. And we're going to do 1F. We're going to sketch the graph of the following parabola. We're going to look for the intercepts and the vertex. So here's the equation. We know that the coefficient of x squared is negative, -2, and so the graph is shaped like a frown and will have a maximum. The axis of symmetry is given by the equation minus b over 2a. B is 6, so minus b is -6. A is -2, so we have 2 times -2. This is -6 over -4, which is 6 over 4, which reduces to 3 over 2. To find the x-intercepts on this equation, we're going to set y equal to 0, which means that -2x squared plus 6x equals 0. We're going to factor this out, the 2x term, from both these terms. -2x times x gives me -2x squared, and -2x times -3 gives me 6x. So when I factor out, I can set -2x to 0, in which case x is 0, and I can put x minus 3 equal to 0, in which case x is 3. So we know y is 0. So when x is 0, y is 0. So that's this point. That's one of the points of the x-intercepts. And when x is 3, y is 0. That's the other point. So here are the two x-intercepts. Now we go to the y-intercept. When we want the y-intercept, we set x equal to 0 for this equation. And if the x is 0, this first term is 0, and also the second term is 0, and so the sum is 0. So when x is 0, y is 0. So we see here that the y-intercept and one of the x-intercepts are the same. You see, we've got 0, 0 for the y-intercept. That happens to be the same as one of the x-intercepts. Now, to get the vertex, we know we need the x value, which is the axis of symmetry, which we just calculated as 3 over 2. We're going to substitute this x value into the equation -2x squared plus 6x. So we get -2, and instead of x squared, we write 3 over 2 squared plus 6x, and instead of x, we're going to write 3 over 2. So now 3 over 2 squared is 3 over 2 times 3 over 2, which is 9 over 4. And then when we multiply that by -2, we get -9 over 2 as the first term. 6 times 3 is 18. 18 over 2 is 9. So -9 over 2 plus 9. Instead of 9, we're going to write 18 over 2 to get a common denominator. 18 minus 9 is going to give us 9 and over 2. So the vertex is the x value and the y value, which is 3 over 2 and 9 over 2 respectively. So when we plot what we know so far, here's the x-intercept. Also one of the x-intercepts also happens to be the y-intercept. And the other one is right over approximately here, and here's the vertex up here. So if we connect this to this and then come down on the other side, we get the shape of the graph, and here you see it right here. And you'll notice that the axis of symmetry, which is x equals 3/2 is right in the middle of 0 and 3. 0 plus 3 is 3, divided by 2 gives you 3/2, so it lies right in the middle. So a way of verifying that we're on the right track. Notice this x-intercept also happens to be the same as the y-intercept. Okay, so let's go to the next problem. And here we have y equals 2x minus the root of 7 squared. So we are going to sketch the graph of this, and we're going to note the intercepts and the vertex. So first of all, I'm going to rewrite this as 2x minus root 7 times 2x minus root 7. The first times the first will give me 4x squared. The last minus root 7 times minus root 7 will give me plus root 49. The root of 49 is 7. So that's the last term. The inner one is minus 2x root 7, or 2, if you like, 2 times root 7x. And the outer one will be the same thing, minus 2 root 7x. And when we sum those, we come out to be minus 4 root 7x. So that's the combination of the inner and the outer term. Now, since the coefficient of x squared is positive right here, the coefficient is positive right here, the graph has a smile shape, and the vertex will be the minimum point. The axis of symmetry, x equals minus b over 2a. So here's the minus, and then b is minus 4 root 7, which is right here, and a is 4, so 2a is 2 times 4. This becomes 4 root 7 over 8. We can divide the 4 into the 8 and get the 2 on the denominator, so the axis of symmetry is the root of 7 over 2. To find the x-intercept, since this is a perfect square, you can see that there's only going to be one x-intercept. We set the y equal to 0. We set 2x minus root 7 equal to 0. We transpose the minus 7 to the right side. We get 2x equals root 7. So x equals root 7 over 2. So there's only one x-intercept, and that will be, the coordinates of that will be root 7 over 2, comma 0, because we set y equal to 0. Here's the x value, here's the y value, there's the ordered pair. Now, to find the y-intercept, we set x equal to 0 in the equation. This term will be 0, and this term will be 0, so y will equal 7. So we have the ordered pair 0, comma 7 as being a value of the y-intercept, the ordered pair that describes it. Now the vertex we get from minus b over 2a. If you go back up here, you can see that the b value is right here, minus 4 root 7. We're going to put that into the equation, minus 4 root 7. It's the same as what we did the calculation before, same as the axis of symmetry. So, and this is 8, so we have 4 over 8, so it becomes root 7 over 2. Now we substitute this x value into this equation in order to find the y value of the vertex. So when we do that, we put 4, which is this 4, root 7 over 2, which is the x value, we square that, minus 4 root 7x. So here's the 4 root 7, here's the x, and here's the plus 7, which is this term here. Now when we calculate this out, root 7 over root 7, root 7 times root 7 is 7. And this 2 times 2 is 4 when we square it, so the 4's cancel, and we're left with 7. from the first term. This one here, we have root 7 times root 7 is 7. 4 times 7 is 28. 28 divided by 2 is 14. And there's, because of this minus here, there's a minus. And now we've got this plus 7 here is plus 7. So the 7 and the 7 add to 14. 14 minus 14 is 0. So the vertex is root 7 over 2, comma 0, which is this point right here. This point right here is the vertex. It's a minimum. We know the graph is going to be shaped like this. And this is the y-intercept here. So we only really have 2 points. Notice, by the way, that the vertex and the x-intercept are the same. So this is where it crosses. This is the x-intercept, and it also happens to be the vertex. So we would connect this point to this point, but we need a point on this side. The graph will go up like this because this is a minimum. It doesn't matter what point we really choose. We can choose any value that's on this side. For example, we could choose the value for x equals 4 or x equals 5. I'm going to choose a point that has some symmetry to it. So the distance between here and here on the x value is root 7 over 2. So if I had another root 7 over 2, I come to some point right here, and the y value should be the same here. And if we add root 7 over 2 plus root 7 over 2, that gives us 2 root 7 over 2. The 2's cancel, and we choose root 7. So we're going to choose a point right here, which is root 7. X equals root 7. And if we substitute that into the original equation, we get 4 times x squared, which is root 7 squared, 4 root 7 times x, which is root 7 plus 7. So this becomes 7, root 7 squared becomes 7. 4 times 7 is 28. The root of 7 times the root of 7 is 7. Minus 4 times 7 is 28, minus with a minus sign on it. And then we've got the plus 7. And so y will equal 7 when x equals root 7. And you can see that this point would be just about here. So what do we have? We have the y-intercept, we have the x-intercept and the vertex, and we have this third point. If we connect all these points together, we're going to get this graph here. Notice that the axis of symmetry x equals root 7 over 2, which is really this point, the line that goes down here, right here, the line that goes down there. Bisects the two x values. So if we bisect 0 plus 7, and we take the difference between that is root 7, and divide it by 2, we get root 7 over 2. So that's just another way of checking that we've done the problem correctly. Okay, so now let's go to problem 1u, and we have to sketch the graph of this equation here. We have to find the intercepts and the vertex. First thing we do is, as we've done before, calculate the axis of symmetry, minus b over 2a. b is minus 2, so minus 2 over 2 times the coefficient of this is minus 1, a is minus 1. So we have plus 2 over minus 2, which becomes minus 1. So the axis of symmetry is x equal to minus 1. To find the x-intercepts, we set y equal to 0. So we take the equation up here, and we set y equal to 0. Now, in this case, b squared minus 4ac is equal to minus 2 squared, which is 4, minus 4a, which is -1, the coefficient here, and c is -3. So this will come out to be 4 times +3, which is 12, but because of the negative sign here, we get a -12. So we'll have 4 minus 12. The discriminant is -8. The discriminant is less than 0. Therefore, there is no x-intercept. What I'm really saying is you can't factor this. There's no way you'll be able to factor this, and you should always check the value of the discriminant, b squared minus 4ac. As I said, b squared is 4. The -1 and the -3 become +3, and then when you multiply that by -4, you get -12. So 4 minus 12 is -8. There's no x-intercept in this for this equation. Whoops, sorry, excuse me. So now to find the y-intercept, we set x equal to 0. So this term will be 0, this term will be 0, y will be -3. So we now know that the y-intercept is -3. There's no x-intercept. So let's find the vertex. We know the axis of symmetry we calculated before, -1. We substitute this into the equation. 3 minus 2x minus x squared, and this becomes -3. Minus 2x becomes -2 times -1, which is +2. And here we have minus, but the x is -1 squared, which would give me 1. And with a minus in front, I have -1. So let's do -3, and -1 is -4, plus 2 is -2. So the vertex is -1 and -2. And because the coefficient of the A is negative, this is a frown. This is going to be a frown. The graph is shaped like a frown and has a maximum. So the vertex is going to be a maximum. And if we, here is the vertex right here. And this is the y-intercept right over here. So this is, okay, here's the vertex, here's the y-intercept, and we only have 2 points. So we would connect this with this, and it would go up, and then it would go down. So we choose a point, x equal -2 on the other side, right on this side, because we have a point on, here's the vertex, this is a point that we're going to connect to this, and then we go over here. And you can see if we went over another -1 to -2, it should give us the same value of -3. So we have two nice symmetrical points. So I put x equal -2 into the equation. Then we get -2 squared. Minus 2x is -2 times -2, and we've got -3. This term is -4. And there's an error here. Excuse me. I'm just going to have to correct this. This should be +4. And -4 and +4, 0, and -3 gives me -3. Let me just put my indicator back here. So go over this again. This term will be -4. This term will be +4 and cancel the first term, and we'll be left with -3. So our third point is -2, -3. So here is our y-intercept right here. Here is our vertex, and here is a third point that we chose. Now notice that at no point does this graph, as we said before, has no x-intercepts. So it will not cross this axis right here. If we connect these 3 points, this one right here, to this one right here, to this one right here, here's the graph over here. So you can see it here is the axis of symmetry. This is the vertex. This is the y-intercept, and this is a third point that we chosen. Now, you don't have to choose x equal minus 2 to get this. You could have choose minus 3 or minus 4, just some point on this side of the line. But we just chose it because it was nice and symmetrical and gave us the same y value. Okay, so let's do the last problem that we're going to do here. Problem number 2 on page 121. A soccer ball is kicked from ground level on a parabolic path. So we know it's curved. Given by the equation minus 0.15x squared plus 2.25x, where y is the height in meters. So this will be the height. And x is the distance that the ball is kicked from where it was kicked. So we have an x and a y axis. The x is the distance that the ball is kicked from where it was kicked, and y is the height in meters. So now, how high is the ball 4 meters from where it was kicked? That tells us x is 4. Okay, so we plug that into the equation, and here's the equation, and x equals 4. So we substitute the x here and the x here as 4. This becomes 4 squared because it's x squared here, plus 2.25 times 4. So if you work this out, this is 16. 4 squared is 16. 16 times minus 0.15 is minus 2.4. And 4 times 2.25 is 9. You can do those on your calculator. So minus 2.4 plus 9 gives you 6.6. So 4 meters from where it is kicked, the ball will be 6.6 meters height. Now, the second part of the problem says, at what distance from where it was kicked does it reach a maximum? So we know from previous cases that the maximum will be along the axis of symmetry. So we need to calculate the x value for the distance to determine where that is. So here, minus b over 2a will give us the x value. Minus b is minus 2.25 right here, and the a is minus 0.15, so 2a. And when you divide minus 0.25 by minus 0.3, because 2 times minus 0.15 is 0.3, you'll get 7.5. So 7.5 meters from where it is kicked, the ball will reach a maximum height. That's the key thing to understand in this problem. Now, what will be that maximum height? Well, we have to plug this x value into the equation in order to find what the height is. So this is just telling us the distance along the ground, which basically is, as I said, the x value. We plug this into the equation. So instead of x squared, I'm going to write 7.5 squared plus 2.25 x. Put that in here. When you work this out, and I worked it out on a calculator, it comes out to be 8.4 meters. Okay, because this term will be positive, but this term will be negative. If you sum, it will be 8.4 meters. So now in the last equation, it asks us when, at what distance from where it was kicked does the ball land Now if the ball lands, sorry this was missing so I typed this in here, at what distance from where it was kicked does the ball land? In order for the ball to land, y must be 0. So we set the equation equal to 0, the y equal to 0, and we factor. And so we set minus x equal to 0, which would give us x equal to 0. So that's just, we set x equal to 0, that means that it landed from where it was kicked, which is impossible. So we only use this solution here, and we put 0.15x equal to 2.25, and then divide both sides by 0.15, solve this part, and we get 15 meters. So 15 meters is the point at which the ball, when it's kicked. So the ball goes up. Let's say here's the ball. This represents the distance along the ground from where it was kicked. This represents up here, the y-axis represents the height, the x-axis represents the distance. So 15 meters from where it was kicked, the ball lands. So it goes up and it comes down and it lands at 15 meters from where it was kicked. So this completes the discussion on page 121.